Well, we have made it through a good section of what we need to know about the network. Now, I'm not going to say that this is the last part, but we need to know how to install and configure some of the things that we work with. So, what I'm going to talk to you about now is installing and configuring different network types. So whether it's cellular, wired or wireless, or even point-to-point networks. So let's jump into our PowerPoint and get started. Oh, sharing my screen would be a good step here. There we go. All right, so as you can see, we are going to be talking about configuring pretty much just the basic Windows networking tools. We're going to be taking a look at proxies and firewalls, as well as using different network features in a Windows environment. Now, Windows is not the only option, but you need to remember that it is the most popular, and that's why we talk about it so often. So let's jump in. All right, so there are different types. Ooh, my apologies. There we go. There are different types of network connections themselves. And we're literally just talking about how you are actually getting on the network. So this is going to be different connections. VPN stands for, I'll give you a second, virtual private network, right? So this is when we're connecting virtually, and we usually use this when we're remoting in. We can use a dial-up connection. We can go wireless through an access point or wired via Ethernet cords. And of course, we can jump onto a cellular connection as well. So now that we have the overall, we can take a look at where we actually start the configuration settings. And in Windows, the set location or set network location is one of the first screens that you come across in older systems and newer, up until about Windows 7. So this is where you're going to configure, well, what they call 3 different networks. You can have the settings for your home and work network saved, and you can actually have settings for a little bit higher of security if you're on a public network, meaning that it's not somewhere that you feel is safe per se. So your home network setting is used for a small network where all of your devices are trusted. This is meaning that you probably have a home group per se set up, and all of your devices can see one another and share resources. Now, a work network is for when you want to configure your devices to be part of a work group. Now, you can see one another, but you don't necessarily have full file sharing privileges here. And public is when you're in a public space. So the settings will automatically apply higher security levels and will try and protect your devices from any unauthorized access. Also, you can't necessarily see the other devices that are on that network, and they shouldn't be able to see you. Now, we've talked about a NIC, or network card per se, and there are different properties that we need to kind of just be aware of per se. And you've got those 3 different networking options that we just talked about, and now we're looking at how high of a speed that you can operate on, and some of the features that may, not required, but may be available for you when you connect to the network. So speed is just that, the highest throughput at the maximum performance. So you might have something that's 10 meg, 100 meg, might be a gigabit connection, just depends on how fast your hardware is capable of transferring data. Now, half duplex is one direction at a time, meaning it can only send or receive. Full duplex means that it can do both simultaneously. Auto negotiation is pretty simple at this level in regards to all of your network devices. That means your NIC and your cable will talk to each other and figure out what are the best settings to communicate data. So it'll automatically negotiate those things. Now, wake on LAN is cool because that means that you can wake devices up from another location, from another computer. So you can tell one device to wake another device up. This is something you need to not only enable on both devices, but you'll need to make sure that your network interface card supports this. Power over Ethernet is awesome, and that enables any of your devices that are connected to a Cat5 or Cat6 cable, and I should just say Ethernet cable in general, to benefit from the actual electrical power that's going through that cable. And last here is quality of service. And that's going to allow us to prioritize different packets or types of network traffic. And we talked about this a little bit before in regards to, I want to give priority to my live or streaming media so that it's not necessarily buffering all the time and pausing. And I can tell my types of services that don't require as much bandwidth, maybe email and my social media profiles, that they're lower on the list, so those can wait and give all the priority to my streaming media. So alternate IP configurations we touched on in IPv4 section, and this is when you want to make sure that you have a PIPA address assigned in case you cannot get the information from the DHCP. Now, there was a specific number that we said was assigned to this situation. If I could not get an IPv4 address, I would get an PIPA address. What was that address? Do you remember? Well, 169.254 is the correct answer, and that's the automatic private IP address that will be sent. But if I want to, I could actually statically assign the address. And that means manual. I would need to put in an IP address, a subnet mask and gateway, and at least one DNS server address. And I can provide an alternate if necessary, but that won't be required. So normally we go for the automatic side and let this happen without any manual configuration. But if you know a certain IP address that you'd like to assign to your devices, even if your DHCP server is not reachable, then this is where you do it. All right, so we've got three different kind of groups per se that we can assign. And a home group is something that you'll use at home. And this is when you have trusted devices, meaning that you want to give more than one user, i.e. yourself, access to some shared resources. And this is great if you have pictures or movies, maybe music that you want to be able to share. So this is a really easy way to share files and printers and any type of physical resources in your home environment, and it works for Windows 7 and 8. Now, work groups are pretty much like unstructured collections is what they call them, of different individual computers that are deployed in smaller offices. So a SOHO environment, small office, home office. And again, this is going to be a place where all of your employees can share resources, usually files. It doesn't matter the file type, but we're going to have a shared folder. And again, you can share printers through here as well for different employees. Now, domains are a little bit bigger, badder version of both of these and come with even more features. It requires a specially configured server called a domain controller, and this is usually bigger corporate or enterprise environments. It has what's called centralized administration, which means the server has a lot of rules that are already set up, and everyone has to abide by those rules. So you won't necessarily have access to everything that's just dumped into the central shared folder, but it's going to be much more organized and have some access control implemented. Now, directory services, let's back up just a step here. What is a directory or a directory service? Well, sometimes we call it a network directory, and it's really just a centralized database that has all the objects. And this includes the users and passwords for servers, computers, and all the devices on the network. And it's stored on usually one server. It can be stored on more than one server depending on how big the environment is. But it's available throughout the entire company or corporate connection. And it provides centralized administration and centralized authentication. There's lots of different types of directory services, but our goal here again is to stay organized and be able to track all of the devices and users that are on our network and what permissions they have or do not have. So we've heard the word proxy used, I'm sure, in a lot of different places. If you were in a school setting or maybe at work and you wanted to get to a website that you weren't allowed to, you may have used a proxy site to get around it. Now, this is not the kind of proxy that we're talking about here. Here, a proxy is a system that acts like an intermediary, if I can get it out of my mouth, for requests for different resources. That means when you request a website and let's say another 1,000 people are requesting that same website, there's no point in going through the legitimate 6 or 7 step process to get that site to load. And that process includes not only making a request within your own network, but going outside of your network to wherever that website is housed on their web server and requesting it and waiting for it to come back into your network and load on your screen. So there's a lot of behind the scenes happening, or a lot of behind the scenes things that are happening when you request an outside resource. So if you have enough people requesting that resource and they're requesting it often enough, the faster, more efficient way is actually to keep a copy of whatever this thing is locally. So instead of going outside of the network and having a session and communicating, you just have it right there inside of your network on your proxy server. So you can actually install proxy software on any client machine, and you can add security levels and tell it what it can and can't keep. But data requests sent from the client usually get routed through this proxy server or client-side proxy before it gets routed to other resources on your network. That means if the information is already on the proxy server, it'll just automatically load from there. It saves a lot of time. A firewall is an awesome tool, and we're using these things every second of every day when we're online. Now, Windows firewalls can be configured for anything in your network to make sure that it's secure against unauthorized access attempts or attacks, as well as that you're only able to reach content that is quote unquote approved. So you see a list of some of the things that firewalls can do as far as enable or disable ports. They're going to filter all your traffic in or outbound, and they're going to keep really good logs of what's going on activity-wise, things that you're requesting, responses that you're getting, where those responses are coming from. It's going to scan all your data for malicious software, whether it's little stuff like pop-ups or big things like spyware and Trojan horses. So the bigger and better your firewall is, the more protected you are. So here's a screenshot of firewall settings. Now, this is pretty simple and the screens will look the same in pretty much every version of Windows. If all the boxes are green, then you're good. However, if one of those boxes is red, that means that there's a problem that Windows feels that you need to address. So that's kind of the basics of firewalls, but I want to take it a step further in this thing called a DMZ. That is a demilitarized zone. It's a small section of a private network that's located between 2 firewalls, and that part is actually made available for public access. So it lets external clients access data on a private system, maybe something on a web server, or if they need access to a printer from outside of the network, but it doesn't allow them to compromise the security of the internal network as a whole. So what this means is we're layering. The external firewall lets public clients access a specific service, and then the internal firewall doesn't let them touch anything on the inside of the network. Well, why in the world would I want the public to be able to reach any part of my network? Well, let's take an example of a bank. Now, if you work for the bank, whose accounts do you need access to? Think about that for just a second. If you're an employee, whose accounts do you need access to? Let's say you work in the call center. Well, any customer could call in, which means you'll need access to every customer's file or account. All right, that's the internal network. Well, what if you're just a customer of the bank? Do you need access to everyone's account? Probably not. You'll only need access to your account. So that means you want to be able to log into your account, see what your account balance is, and maybe manage your account details. Well, you only need access to yours, and so that access is going to be granted in the DMZ. Now let's take one step further out. If I am not a customer of that bank in any way, shape, or form, I have no account with them, I'm not an employee, and I have no intention of opening an account. Do I need access to anyone's account at that point? Not at all. Not until I have my own account, which means I want to be able to maybe load their website. But once I go to log in, I shouldn't have any credentials and no access to any account within that bank. And I really should not have access to all the accounts in the bank. So those are the three layers. You have the internet all the way outside for non-customers. You have the DMZ, where a client of the bank would need to access their own account. And the internal network is where your employees would have access to, which is all the accounts. So hopefully that helps break that down. But this is great for organizing and allowing some access to what's called a public resource without letting anyone into your internal network. Now, NAT is a concept that you use every day and probably don't even know it. NAT stands for Network Address Translation, and it's used to conceal internal private IP addresses from an external network. Well, let me break this down a little bit. How many devices do you have in your house that are online pretty much all the time? So think about your laptop, your cell phone, maybe one of your gaming systems. For those of you who have fancy appliances, your washer, dryer, or refrigerator might have an IP address now. That is a thing for those of you who are not caught up, but a lot of things have IP addresses, and if you don't live by yourself, then you probably have multiple phones, multiple laptops, and different things connecting to your network. Now, not every single one of those is going to have an external or publicly facing IP address. To be honest, none of them will. They'll all have a private address. Now, you need at least one public address to make all of these requests through your router. And your router handles your NAT or NAT. Now, your network address translation is what allows all of your devices to communicate and flow all of these requests through your router. Your router then is going to smack this public IP address on them, make all the requests on your behalf, and then when it gets a response back, it's going to know to route the appropriate request back to your cell phone and back to your TV and back to your gaming system. Because if we're trying to watch Netflix on our television, we don't need it trying to open up on our tablet. And if I'm requesting a social media app on my phone, I don't want Instagram popping up on my TV. So NAT is what allows the organization for all of these requests and responses without necessarily needing all public IP addresses, which is great. It can be implemented on software, as software on a bunch of systems, but in your home, your router is actually what's going to handle this. Now, it can also be implemented as hardware as far as having a dedicated device. And this is when you get into larger routers and enterprise level systems, you're actually going to have NAT as its not own piece of hardware per se, but integrated into your router at that point. So DNAT is dynamic NAT. So let me back up a little bit. You have static NAT and dynamic NAT. Static NAT means that there is an internal address mapped to a specific public address. So this takes us out of that one-to-many situation and puts us in a one-to-one situation. Now, that in the static side, every internal address is manually assigned, statically, remember, manual and static are the same, manually assigned to one public address, which means in this example, your 192.168.25.101 will equal 211.14.248.68. Always, they're statically assigned. They're kind of semi-permanently married together. So I will always have a public-facing address, and it's not going to change. Now, in dynamic NAT, there's not necessarily a one-to-one ratio that is going to be the same all the time. What will happen is, as my internal addresses need to communicate with the outside world, they will pull a specific public address from a different pool that's available. Meaning I have this big list of addresses and it's just going to grab one and use it until it doesn't need it anymore. So sharing is something that is great in regards to being convenient, but it might not be the most safe. So let's talk about sharing and where it's appropriate. One of your duties, to be honest, as a tech is going to be supporting users with some pretty basic network tasks. And if somebody doesn't have access to the shared folders or resources per se that they need, then it's going to be really hard for them to do your job. On Windows system, it's pretty straightforward as far as sharing folders. You'll right-click on that folder and go to Properties, and you'll have some different tabs. And you have a security tab, and in that security tab, there's a button that says Properties, and you'll be able to fix or modify your share permissions, meaning that whoever L. Huber is, in our example, can then share folders and files with J. Smelt, and whoever else necessary, as long as they have access and permissions. Now, file sharing with Apple is pretty much the same, but there's some restrictions here. You can only share with up to 10 other users without having a file sharing server. So be aware of that, there are some restrictions. With Unix or Linux, a centralized file server is really common. So when we have an OS that's Unix or Linux, we are not necessarily by default implementing ad hoc or what's called peer-to-peer resource sharing. We usually have some type of network file system, and you see it up there as NFS, and that's allowing us to share files with other Unix and Linux systems. This is what enables our clients to see files on a shared system, even if they were not necessarily local, but they can see them from wherever they can sign in. There are specific steps for implementing this within your Linux or Unix environments, but I promise that that is not going to be part of your test. And to be honest, if you're in a Linux or Unix environment, there is probably some specific steps that your system admin will have you review, because there are a few different ways to set this up. Those environments are customizable, and that's good because usually they're much more secure. Now, administrative shares is quote unquote a higher level. This is where you have hidden files, and those are actually marked with a $, as you can see on your screen. So $C$, $D$, and that actually means that it's an administrative level folder. Most of these are hidden by default, and you can unhide them if necessary. So certain folders in Windows are default shared, and they can be deleted, but the system is going to recreate them every single time it restarts. So why in the world is this? Well, these files are per se important, and you can connect your hidden shares by giving them what's called a universal name convention, but they're not necessarily visible by default on your network. You can see all the shares on your system, even the administrative level, if you open your computer management and expand all of your shared folders. And you'll be able to see even the administrative shares on every Windows system. Again, you need to be an admin to do this, but understanding the file structure in Windows is best if you go and take a peek at what's going on. The more you understand about this, the more control you have over your computer. Remote desktop is awesome, but I will tell you that one of the first things that we always come across is somebody saying it won't work and I don't know why it won't work and I did all the steps correctly. Well, one of the things that we always seem to be forgetting is that you need to enable or allow remote desktop. You see on your screen a screenshot of your system properties, and you see the little radio button that's selected right now is allow connections from computers running any version of remote desktop, which is a little less secure than allowing computers to connect that have remote desktop with network level authentication. But the first option you see there is don't allow connections to this computer. And that's actually the default selection. So if you want to remote into a computer, You need to make sure that on both sides, at the absolute minimum, the receiving side, meaning the one that will be remoted into, needs to allow computers to connect to that computer remotely. So what is remote desktop? If you haven't used it before, it gives you the ability to operate a computer from a remote location, literally as if you were right in front of it. Now, depending on the permissions, again, you'll need to configure this to be usable, meaning enable it first. And then you can actually define what type of access you have. You can have full access to all resources, even the things it's connected to, like printers or storage devices. You might reduce that capability or access, saying that there's only certain files or folders that someone can access via remoting in. Totally up to you. Now, the biggest limitation in using the Windows provided remote desktop is that only one person can be logged into the machine at a time. So if you're remoting in to the local computer, that means no other user can log into it at that time, or if they do attempt to, someone will be kicked out. Now that means two people are remoting in at the same time. Now let's talk about if you're remoting in and then somebody sits down in front of it and logs in. Well, then your remote connection will be disconnected because the local user takes priority. Really quick, what is a SOHO? Do you remember what the acronym means? Small office, home office, right there at the top. Get that into your flashcards and your memory because you'll see it in the future. Now, SOHO network is something that provides connectivity for a small office, and it's usually considered 20 computers or less. Now, computers is the right word, but at this point, it's really devices. So maybe a few computers, laptops, a few cell phones, but 20 devices or less is usually considered a SOHO environment. And usually this is a place where you're sharing files and resources, as well as having a centralized management for email and different online services, maybe even faxing if you're still using that. So a SOHO network can contain a combination of wired and wireless devices. Usually your PCs will be wired and all of your other devices will be wireless. So I don't want you to think of any restrictions other than the fact that they should all be in the same physical place, in the office environment. Now, QoS is something that we've briefly touched on a few different times. So let's jump into some detail here. How much data being transferred over any network is increasing every single day. So the type of data that's being transferred is always changing. Now, we used to really just focus on transferring files and logging into things, but now we are pretty much bombarded with real-time media and using our phone over our computer at the same time. Not our cell phone, but VoIP phones in office space. We're using a lot of multimedia applications and we're video conferencing more and more. Some of you are actually watching this live as I speak, and that is considered video conferencing and real-time multimedia. So even though your file transfer and some of your classic or traditional applications are really sensitive to packet loss, but it's okay if there's some delay, meaning if I'm sending something that needs to be rebuilt perfectly at the other end, that means it's going to grab all the pieces of that packet and restructure it appropriately before it gets delivered. And if that takes a few extra seconds, then so be it. But that's not the case when we're talking about multimedia applications. It's a lot better to lose some of your packets than to delay the entire delivery. Remember I talked about basketball and my football games are already long enough. I would hate for them to buffer for hours and hours just so I can see every single millimeter of motion that a player goes through. Now, what would cause some of these delays? Well, the first one that you're going to come across, and probably the most popular problem, is not having enough bandwidth. And that results in really bad quality transmission for these data-sucking real-time applications. So this can be a major problem in small offices because their network just cannot necessarily handle how much data is being transferred. Well, this is where QoS can come in and start to save the day. Your quality of service parameters mean it's going to take the maximum amount of delay that it could possibly have and take into account the signal noise and signal loss that can be accommodated with different types of network traffic. And it's going to start assigning priority, bandwidth priority, to what's real-time or multimedia, and letting those things that can take a few more seconds to build, well, it's going to tell them to take those few more seconds because something else at that point has priority. Now, what handles all of this? Well, your ISP is going to be a major player. All the parameters that we're talking about have to be agreed upon by the transmitter and receiver, and your transmitter is your ISP. So you're the receiver, i.e. the subscriber to this service, and everything's got to be negotiated and agreed upon before you can enable QoS. Now, that's not a phone call or an email conversation with your ISP. It's something that happens digitally in the background. But once both the digital transmitter and digital receiver enter into some type of agreement of how much bandwidth will be used, then it's going to be, per se, logged. Now, I said that this did not include a phone call or an email conversation, but let's step into the place where you've had enough and you need to upgrade your service. You're ready for faster internet. So you call your ISP and you're telling them, bump up your service. Well, that's where that conversation and that agreement gets put on paper, meaning you have a new contract. You're going to pay a little bit more, they're going to provide a little bit more. And that contract is called an SLA, a service level agreement. All of the details are going to be housed in that contract. If for any reason your ISP fails to provide the level of service that you signed up for, i.e. the speed, then you have the right to call them and complain. And per se, there are penalties. And the penalties are usually them giving you some type of partial refund for the inconvenience after a million hours on the phone. So you have to decide if it's worth the investment and make sure you have a really good ISP. But if you're stuck with certain companies like I am, then you're just going to have to find the breaking point and get on the phone when you just can't take it anymore. But nonetheless, you are in a contract or contractual agreement with them. So anytime that you've agreed to pay a certain amount and they've agreed to provide a certain amount of service, in this case, our bandwidth and how fast our internet speed is, then they can be held responsible for it. Now we're going to review again our 802.11 standards, and I do this because they are important, but I'll go through them quickly. 802.11a runs at 54 meg and 5 gigahertz. That's the frequency. 802.11b has the slowest of our options at 11 meg and is on the channel of 2.4 gigahertz. 802.11g, 54 meg again, but this time 2.4 gigahertz. 802.11n as in November. Oh, yep, N is up to 600 and operates at both 2.4 and 5 gigahertz. 802.11ac can transfer up to 1.3 gigabits and at 5 gigahertz. And I'm getting this feeling I skipped G. So just in case I did, 802.11g runs at the speed of 54 meg and at 2.4 gigahertz. I honestly don't know if I just said that. But we have all these numbers and we need to know what these gigahertz things are. Well, let's take a moment. So let's just focus here on our 802.11, B as in Bravo and G as in Golf. And we're looking at, literally on our screen, 14 channels. Well, those are 14 different individual channels within the 2.4 gigahertz band. Every channel is composed of a range of frequencies transmitting at low power. This is not necessarily a single frequency that transmits at a super high power. And this is good for us because data from a single transmitting node per se, a single device, is actually spread across all the frequencies in a channel. And because the overall frequency range is limited per se, the band, the channels can be implemented with a lot of overlap, and that overlap is what you're looking at on your screen. Now, we're talking about making a picture out of this wireless concept, so it can be a little bit difficult to understand. But what you need to what you need to know is that there are special codes embedded in the signal, and that gives each transmitting node a distinguishing pattern. That way, a lot of different devices can actually share the same channel at once. That's a lot of fancy words for you can have more than one device transmitting on the 2.4 gigahertz channel and not necessarily have a whole bunch of overlap. Where's an example of this? Let's tie it together. If you are in a home that you use your laptop in the kitchen or maybe on the other side of the kitchen in regards to where your router is, meaning your router's on one side of the house and your device is on the other side of the house, and somewhere in between is your kitchen. Now, have you ever noticed a slight decrease in your Wi-Fi signal when you use your microwave? Well, if you're close enough to your microwave, you will actually see a pretty distinguishable reduction in your Wi-Fi signal. And that's because your microwave operates on 2.4 gigahertz as well. So these are multiple devices operating on the same channel. Now, I use that example because the microwave is powerful enough that it's using more parts or a bigger section of the spectrum than two devices can use simultaneously. And it will pretty much overpower that signal just while it's on and operational. So this will hopefully help you understand that there's a spectrum per se, or different channels within a single frequency. And the reason this happens is so that we can spread it out and use more than one device simultaneously. Another device that operates at 2.4 is your Bluetooth. So if you have a headset or any Bluetooth connection, that again is operating at 2.4 gigahertz. So now that we know how to get online, let's talk about how we secure ourselves online. One of the first things that you have to do, unless you're on an open network for Wi-Fi, is to log on. So that means you need to know the name of the network and the password. So we're just going to focus on the password part here. Now, encryption itself is literally just the process of converting data into a form that's not necessarily recognizable, meaning it's not 1, 2, 3, ABC. Now, even if that is your password, which it shouldn't be, it's not going to be sent in clear text across any type of network. Now, some encryptions are actually only one way, which means it's designed to hide the clear text and it's never decrypted. Well, you can have two-way encryption, which is a little bit more common, which means the text can be encrypted and decrypted, which means it can be hidden and then reversed back to its original form. So there are three different types of wireless encryption that are pretty popular. Now, WEP, wired equivalent privacy, is not something that you see too often because it's outdated and it's weak. It provided three different levels of encryption, and just in regards to the length or strength of the encryption. And it was only good to use on 802.11a and b. Now, it was an awesome solution when it first came out because it was pretty much our only solution. But the fact is that it was weak, and within a really short period of time, people were able to come up with software to pretty much crack the algorithm, which means they could hack into your connection with ease. So then we created what's called WPA, which is Wi-Fi Protected Access. And this was introduced to really fill in the holes of WEP, meaning that it had stronger authentication and data encryption. It provided encryption through what's called TKIP, TKIP. It stands for Temporal Key Integrity Protocol. And this was created by the IEEE, which is one of those organizations that writes a good amount of the rules that we abide by in IT. And it was supposed to completely replace WEP. And it almost has, to be honest. Now, it did combine the existing WEP encryption and took it to pretty much the next level, and it fixed some of those key issues that were the weaknesses of WEP. Well, that worked for a while, and it's still in play today, but we now have an even better version, and that's called WPA 2. Now, this is the strongest wireless standard that you see being used in enterprise solutions. It is authentication security to the max, per se, and it relies on what's called 802.1x as an authentication mechanism. Now that's all fancy stuff, but let's break it down to what this actually means. It uses a bigger, badder version of an advanced encryption standard that's called CCMP. And you don't need to know this for your test and pretty much anywhere. You do need to know CCMP, but you don't need to know what it stands for. But I'll tell you anyways, because it's a crazy amount of info. It is Cipher Block Chaining Message Authentication Code Protocol. CCMP is an acronym within an acronym, and it's a long one. Again, it's Cipher Block Chaining Message Authentication Code Protocol. And the goal for this is to provide better security than TKIP and eventually replace it. So when you're at home, you're probably using WPA, but if you have an upgraded router and your ISP supports it, then you're probably using WPA too. But when you get to work, I am willing to bet if you're in a larger size office, you are using WPA too. A wireless access point is the device that allows you to connect wirelessly to your network. It can also provide wireless access between different devices directly, meaning it can do it without necessarily being hooked up to a router. Now, just for a quick reference, take note of this. In your test and in real life, some people call a wireless access point just an access point. So you might see it as an acronym of just AP instead of WAP. Now, that doesn't mean that an access point is not providing wireless access. It's just that we can refer to it as either one. And I want to make sure that you're comfortable with that in your testing environment. SSID is Service Set Identifier. Again, Service Set Identifier. What is an SSID though? Well, it's just the name of our network. Whatever you've called your network. You might call it Bob's Wi-Fi or my access to Google. You might have one of those crazy ones to scare your neighbors, like some type of surveillance van. My favorite was when I lived in a different state. My Wi-Fi network was called Shut Your Kids Up because there were super noisy kids playing basketball in the apartment above me. And so when I did that, I think within about 2 days, my neighbors had noticed. And it definitely got a little bit quieter, but that only lasted about a week. But this is whatever you've decided to call your network. And when people look up the available networks, let's say they want to jump on Wi-Fi on their phone, they're going to see your SSID on their list of available networks. Port forwarding and triggering. Now, first and foremost, this is if your router has NAT, Network Address Translation. Then you can also configure port forwarding. And that means you can forward a network port from one network node to another network node. That means that you can forward information from one place to another. Now, port triggering is what automates port forwarding by specifying what ports are going to be forwarded, meaning that you can automatically forward inbound traffic to a different place. Again, port forwarding is moving the traffic, and port triggering is what makes it automatic. Now, once you have your router in place, you need to understand that there are some basic settings that you should be changing. Please change your defaults. Don't let your username be admin and your password be password, or password1 or password123. It's not secure, and this is how you get hacked. Now, I'm not going to go through each and every one of these with you, but I do want to talk about MAC filtering because this is a really cool option that you have. Now, applying MAC filtering will allow only certain MAC addresses to access a network, use your network, pretty much get online in your house. Now, this is not something that you see implemented in big enterprise environments. This is something either at home or in a SOHO environment because it's pretty labor intensive once you get beyond a certain number of devices. You would actually have to manually enter the MAC address for each device that you want to be able to access your network. That means only those devices can get on the network, even if somebody has your username and password. If their MAC address isn't on the list, they can't get online through your router. All right. The other thing I want to touch before we move on from this slide are channels. Now, we talked about how channels work per se, and you need to understand that we can choose between 1 and 11 for our router channels. So make sure that first and foremost, you change the default channel on your router. But you need to understand that by doing this, you're optimizing data transmission, and the most important part is you're reducing interference with other routers in the area. So let's say your neighbor has decided to use channel 1, and the person above you has chosen channel 11 because they're the farthest apart, and that's what reduces interference the most. Well, you're stuck in the middle, so what do? Well, channel 6 is your best bet. The most common channels that people use to stay away from each other per se to reduce interference are using channels 1, 6, and 11 because they are technically the farthest apart. And you'll need to know that when you're implementing any type of router configuration. Now, router is a piece of hardware, so you know that you have firmware. Any device has to have firmware, and you'll need to update it. I would recommend updating your firmware when you pull the thing out of the box, as well as, well, let's call it every 3 to 6 months, take a quick check and make sure it's up to date. So, why in your router is there firmware? Well, it's hardware, so it's going to have new features. It might have some security patches that need to take place, or even some just type of general upgrades to the rules and regulations as to what's going on. Each of these are going to be manufacturer specific, and you should be checking pretty regularly throughout the year on what the new firmware version is. UPnP. Well, you probably know what PnP means, but you probably haven't heard the U in front of it. And this just stands for Universal Plug and Play. It's built into most wireless routers and most of our devices at this point. But just on the networking side, this is what allows our computers and printers and other devices to be really easily discoverable by our router. That means that that signal that's being let off is going to be discovered and the communication can start. While it might make it really easy for you to connect, it also makes hackers' life, well, pretty simple when it comes to hacking your network. Not only discovering your devices, but take advantage of all of the features of universal plug and play as well. Because once they're on your network, they can see pretty much anything. All right, so you've learned a lot in that one. This is probably one of the chapters that has the most new information because if you're just a normal end user and you're not necessarily in IT yet, you've been able to plug and play into your life as far as the IT side is concerned. But you haven't necessarily had to configure these devices yourself and maintain them on a regular basis. So make sure that you take the time and go discover what's going on in your own home with your own router and devices. Now, please don't break anything because I'm not going to come and fix them for you. I know that. But go do your IP config, trace route to a different website, and see what your router connections are doing. Take a look at the speed and settings, maybe jump into the administration portal for your router at home, and start familiarizing yourself with how to set these things up and where the options are. Again, please don't make any major changes unless you know what you're doing, because I can't come to your house and fix it for you. All right, study hard, make flashcards, and I'll see you soon for another lesson.